Hey everyone, welcome to this explainer. You know, if you've ever looked at a bunch of math jargon and thought it felt like a totally foreign language, well, you are absolutely in the right place. Today, we aren't just going to sit here memorizing dry definitions. Instead, we're building a highly practical mental toolkit. We're going to take those abstract concepts of multiples and factors and literally turn them into real-world problem-solving superpowers.
Okay, here is our roadmap for today. We'll start by meeting the multiples, then move right into the lowest common multiple. After that, we'll figure out factors, explore the highest common factor, and then for the fun part, we'll put it all to the test with a real-world math challenge. Let's get right into it.
Section 1. Meet the multiples.
So what exactly is a multiple anyway? Well, the simplest way to think about it is really just as a times table for a specific number. It's simply what you get when you multiply a number by a positive integer, like 1, 2, 3, and so on. Now, there are two golden rules for multiples that are absolutely crucial to remember. First, the very first multiple of any number is always the number itself, right? Because anything times 1 is itself. And second, multiples go on infinitely. They literally never stop.
Let's make this a bit more concrete. Say we want to find the first 5 multiples of 12. We just start multiplying by 1, 2, 3, and so on. 12 times 1 is 12, 12 times 2 is 24, all the way up to 12 times 5. So our first 5 multiples are 12, 24, 36, 48, and 60. You're basically just rolling right up the times table.
All right, now that you've kind of got the hang of it, I want to challenge you a bit. Is 300 a multiple of 12? Now, since multiples go on infinitely, we obviously don't want to sit here and write out our 12 times tables all the way up to 300 just to check. That'd take forever. Take a quick guess in your head right now before I reveal the trick.
Okay, so this brings us to a super handy division trick. To check if a really large number is a multiple of a smaller one, you just work backward. You take the large number, 300, and just divide it by the smaller number, 12. Because 300 divided by 12 equals exactly 25, with absolutely zero remainder, the answer is a resounding yes. It divides perfectly, which confirms for sure that 300 is indeed a multiple of 12.
Section 2. Lowest common multiple, or LCM for short.
The lowest common multiple, or LCM, is exactly what it sounds like. It's the smallest number that happens to be a multiple of 2 or more numbers. You can kind of think of it as the very first shared answer between different times tables. And here is a fantastic real-world hint for you. LCM is the tool you reach for when you want to synchronize events that are happening at different intervals, and you really want to know when they're going to happen at the exact same time again.
Let's see how this builds using the numbers 4 and 7. If we list out the multiples of 4 on the top row and the multiples of 7 on the bottom row, we just need to scan from left to right. We're looking for the absolute first number that appears in both lists. And boom, there it is, 28. So the LCM of 4 and 7 is 28. Simple as that.
All right, shifting gears a bit. Section 3, figuring out factors.
A factor is a number that divides exactly into another number without leaving any remainder whatsoever. If multiples are about multiplying outward and getting bigger, factors are like the perfect little building blocks that fit exactly inside a number. Now, there are a few golden rules you got to remember for your toolkit here. Number 1, always a factor of every single number. Always. The absolute largest factor of any number is just the number itself. And finally, factors almost always come in pairs that multiply together to give you that original number.
Now, putting these two concepts side by side is where things really click into place. Multiples are the times table results stretching out infinitely. They just keep getting bigger and bigger. Factors, on the other hand, are the exact building blocks that fit inside a number. They're totally finite and they hit a wall, stopping at the number itself. So basically, multiples multiply outward, while factors divide inward.
Let's actually see these building blocks in action. For 12, we find pairs that multiply to 12, like 1 and 12, 2 and 6, and 3 and 4. If we list them all out, those are our factors. For a number like 25, we only have 1, 5, and 25, because we never repeat numbers in pairs. We wouldn't say 5 and 5 twice, right? And even for a much bigger number like 110, we just systematically find those multiplying pairs and list them in numerical order to get our complete, perfect set of factors.
Section 4. Highest common factor, or HCF.
The highest common factor, or HCF, is exactly what it says on the tin. It's the largest single number that is a factor of 2 or more numbers, and just like LCM had that real-world superpower for synchronizing schedules, HCF has one too. You're going to use the highest common factor in real life when you need to split different quantities of items into the absolute largest possible equal groups or rows.
Let's find the HCF for 8 and 24. First, we just list out all the factors for both numbers. Then, we scan both lists for the factors they share. In this case, looking at them, they both have 1, 2, 4, and 8. Finally, we just pick the absolute highest number from that shared list. The highest common factor here is 8. It's completely approachable when you break it down visually step by step like this.
Moving on to Section 5, the Real-World Math Challenge.
Okay, here's the challenge from our source material. We've got a guy named Simeon, and he has 2 lengths of rope. One is 72 meters, and the other is 90 meters. He wants to cut both of these lengths of rope into the longest pieces of equal length possible. Now, maybe Simeon is just really obsessive about perfectly equal ropes, who knows? But the question is, how long will the pieces be? Before we dive into solving it, I want you to think about our tools for a second. Are we trying to synchronize events with multiples, or are we trying to divide items into the largest equal groups? You guessed it, longest pieces of equal length is the ultimate clue that we need to use our highest common factor.
So, the crucial step here is listing our factors completely accurately. We break down all the factors of 72 and all the factors of 90. Now we visually scan these two sets hunting for the absolute highest match. Sure, they share smaller numbers like 1, 2, 3, 6, and 9, but if we look a bit further down, the highest shared number standing out right there in both lists is our winner.
And there is our solution. The highest shared factor is 18. This means Simeon must cut both of his ropes into 18-meter pieces to get the longest possible equal lengths, without wasting a single inch of rope. It's honestly incredibly satisfying when the math snaps together to perfectly solve a physical problem like this.
Look at what we've accomplished today in this explainer. You aren't just staring blindly at math terms anymore, you actually have the tools. You know for sure to use multiples when you need to synchronize schedules, and you know exactly to use factors when you need to divide resources efficiently. So I'll leave you with this. Knowing what you know now, which real-world problem are you going to solve next? Keep observing, keep learning, and I'll catch you in the next explainer.